When Oasys Pile is used to calculate settlements, we need to click the analysis. In the analysis option, we need to click the settlement analysis on. Also, we have two methods to calculate settlement in Oasys Pile. One method is the Mindlin method and the other method is the use of TZ curves. If TZ approach is selected, then input the relevant TZ curves and tip load curves to be used for pile shaft and pile base respectively. A particular type of TZ curve can be selected by double-clicking the appropriate type under the TZ curve data or tip load curve data on the gateway, or it can be accessed under the material properties TZ curve data or tip load curve tab on the home ribbon. Pile 20 has 6 types of TZ curve data and tip load curve data input built into the program. The first type is the elastic plastic TZ curve, wherein you need to input the Young's modulus at the top of the soil layer and the gradient at which the modulus changes down the layer. Poisson's ratio is the Poisson's ratio of the material, and Rm is the radial distance at which shear stress in the soil becomes negligible. The second type is the logarithmic curve, wherein you need to input the Young's modulus at the top and the gradient as before. Also the Poisson's ratio, the radial distance at which shear stress becomes negligible, and the psi or the portion of peak force which is the yield force, W peak which is displacement at peak force, psi soft for the fraction of minimum peak post peak force, WRES for the post peak displacement to minimum post peak force, and eta which is the shape parameter controlling the rate of degradation. The next one is the Chin and Polo's curve, where you have to input the Young's modulus at the top and the gradient at which it will vary, the Poisson's ratio, as well as other factors which are the hyperbolic curve fitting constant, the curve fitting constant for the unloading part, the reloading curve fitting constant, and the degradation constant. The next curve is the API, wherein you need to specify the material type and then the ZC, the movement required to mobilize maximum stress. So this will be active only when the material is sand. And for the clay material or cohesive material, the data to be entered is Trs by Tmax, which is the ratio of mobilized stress to maximum stress. Next type of curve is the Vijay-Vergia curve, wherein the description has to be input and the value of ZC, which is the movement required to mobilize maximum stress. This value is often around 0.3 inches for sands. And finally, we have the user specified curves which can be used by the user to input values which they think will be suitable for their analysis. So if I click on user defined, okay, so there are two data fields to be input. This is the local shaft displacement Z. This can be normalized by selecting the normalized radio button, and by default it is absolute. And the next data is normalized shaft shear stress, or T by Tmax, the ratio of the mobilized shear stress to maximum shear stress.